So we move on now to a discussion about how we describe matter. Now we can describe matter in a couple different ways. We can describe what it is now, and we can also describe it as what it's going to become later. The two ways we do that are with properties and changes. A physical property, a chemical property, a physical change, and a chemical change. First, let's talk about physical properties. A physical property is one that can be observed without changing the substance. So the substance remains the same. Substance stays the same. There's two different types of physical property. Extensive and intensive. Now, an extensive physical property is dependent on amount. A couple examples of this would be something along the lines of mass or length or weight, if you were to use that measure. An intensive physical property does not depend on the amount, so it's independent of amount. An easy way to keep those two straight is to focus on the eyes. Independent of amount is intensive. An example of something like this would be density. No matter if you have an oak cube or an oak tree, it still has the same density, the ratio of its mass to its volume, something that we'll be discussing here in the future. A chemical property is the ability of a substance to change into something else. Ability to change into a new substance or a different substance. Now, the crazy thing about chemical properties is that they can only be observed by actually doing that change, by actually going about and making the change. Wood will not rust. We know it won't rust, but the only way to actually figure out if it'll rust is to expose it to the types of situations that would bring about rust, moisture and air. Iron, on the other hand, does have the chemical property of rusting. Another example that I could give is that metals react with acid. Not all metals, but most metals react with acid. But the only way to actually know that a metal reacts with acid is to actually put acid onto a metal. Now, when we talk about physical and chemical changes, we're talking about something a little bit different than physical and chemical properties. Now we're trying to talk about what happens to matter as it does go through a change. Now, a physical change does not change the substance itself, so you end up having the same substance. A chemical change, however, results in the formation of a new substance. Some very common physical changes would be those that change the state of matter. For example, when ice melts, ice melting into a liquid still means we have H2O. On the other hand, if we take, say, bread and change it to toast, we have a new substance altogether. And the properties of the toast are very different than the properties of the bread. Compare that to the physical change. Water still has the same boiling point, same melting point. Though the density does change, many of the properties are retained, and we do have the exact same substance. Here we have 4 pictures. From these pictures, hopefully you can figure out what kind of properties are being represented. Are we talking physical properties, or are we talking chemical properties? In the upper left-hand corner here, we have a tape measure. And tape measures measure length. So because we're talking about length here, we're talking about a physical property. Now, we could get even more specific and say that this is an extensive physical property. And it's an extensive physical property because length is very much dependent on what we have. If we have a pencil that's a certain length, we could also break it in half. Now we're talking about a different measurement. And because it's a different measurement, it's a different physical extensive property. Up here, you can note that the top of this penny is developing a green coating. That green coating is called patina. And that's what happens when copper pennies are exposed to an increased or high amount of oxidation over time. Now, the only way to actually find out if this copper will form a patina is to expose it to it. Therefore, this patina forming on the penny here is a chemical property. In the lower left-hand corner, we have some iron nails. Now, these iron nails don't look like regular nails. They have an orangish tinge to them. Hopefully you were able to see that this is a rusting effect. And the only way to know if something rusts is to actually have it rust. So this is a chemical property as well. The last picture could be a little bit more difficult. We have wooden planks floating on some water. Now, flotation in itself is not necessarily a property. But what causes flotation to take place is the fact that our raft here is less dense than the water that it's floating on. And density is a physical property. Furthermore, it's an intensive physical property. Okay, on this slide here, you can actually test to see what you know about physical changes and chemical changes to see just how well you kind of grasp the material. We'll do the first one together, and then I'll give you an opportunity to go through and try and solve the rest before we move on. Sodium hydroxide dissolves in water. Now, when something dissolves, it doesn't necessarily go away. You don't see it anymore, but it still retains its properties. For example, if I were to take salt and put it into a large body of water, you would still taste the salt. We call that the ocean. So in this case here, sodium hydroxide dissolves in water. We have a physical change. I'll give you a minute now to go through the other bullet-pointed examples and see if you can figure out if we have a physical or a chemical change taking place. At this point, if you need additional time to complete these problems, please pause your video as we will move on to the answers. How'd you do? How's your understanding of physical and chemical properties and changes? If you have any questions, please be prepared to talk about this in class. As an additional task, I want you to bring something with you to class tomorrow. I want you to bring an object, any object of your choosing. Now, with this object, we are going to determine some physical and chemical properties. Physical and chemical properties. You will be destroying this object, so it needs to be something that you do not consider valuable, something cheap. For example, in the years past, I've had students bring in a rubber ducky, or somebody brought in a McDonald's toy. And what we'll be doing is we'll be doing our first lab of the year with this object. So please remember to bring this object with you to class tomorrow. Again, it needs to be cheap, and it needs to be valueless, meaning that you will not care when this thing gets destroyed. That's all we have for physical and chemical changes and properties. Look forward to talking about it in class tomorrow.